Welcome to John Newton online class. In this video, I want to teach you the parameters of motion. And remember last time we started our topic online here on motion, which is a basic concept in physics. Now, having discussed the concept of motion last time, like I promised that we shall be taking it topic by topic. Now, this class today, we are going to discuss the parameters of motion. And what do we mean by that parameters of motion? We mean those physical quantities that we use to describe motion of a body. Remember, when we say a body, we mean any object or material or matter or substance. So those physical quantities that we use to describe or determine or measure or express the motion of a body. These are what we mean by parameters of motion. And what are they? These parameters of motion include the following. We have time. We have distance or displacement. Then we have speed or velocity. Then we have acceleration or even retardation. We also have acceleration and retardation. So these are the basic parameters of motion. Now let's take them one by one. Now time. When a body undergoes motion, remember we said that motion is the change in position of a body with respect to time as measured from the frame of reference. Now, time simply means the duration of an event. Yes, the duration with reference to before and after, to which an event lasts. That is the time. So, now, what is the unit of time? Time is measured in seconds. The SI unit of time as a physical quantity in physics is what? Seconds. So, time, measure time, which is T, in seconds. Record that 60 seconds make 1 minute and 60 minutes make an hour. That's it. Then let's look at the second one, displacement or distance. By distance, we simply mean the separation or gap between 2 points or between 2 planes, 2 points in a plane. So when a body takes off from a point and covers a gap from one point to another point, from one station to another station, for instance, a car or a vehicle taking off from a station to another station, that is now the gap in that motion covered within the time given is what? The distance or the separation. And that distance or displacement, that displacement is that distance called when it is measured in a specified duration. When the distance is measured in a specified duration, then it becomes displacement and it is a vector quantity. But distance is just the total gap covered. That is in terms of scalar quantity. So the SI unit of distance or displacement is what? Meter. And you should recall that 100 centimeters make 1 meter. While 1,000 meters make 1 kilometer. So we use this is S and meter. And we use the letter S to symbolize or to denote distance or displacement. Now let's look at speed or velocity. When we talk about speed or speed simply means it is the distance traveled per unit time. That is it. The total distance traveled per unit time or total the ratio of the distance covered to the total time taken in the distance to cover the distance. That is the speed of a body in motion. Or velocity is now the speed measured in a specified duration. That is, the velocity now is the time rate of change of displacement. That is it. The time rate of change of displacement gives you the velocity of a body, while the time rate of change of distance gives you the speed of a body. Both of them are measured in meter per second. That is the SI unit of velocity or speed is meter per second. Now, we can now see that velocity, we use V. V simply is S over T, and it is measured in meter per second. Meter per second. So the velocity is the distance over time. That the speed is distance over time. Both the distance and the displacement is denoted by the letter S or with the letter S. Then we can now see mathematically that velocity of a body in motion is obtained by dividing the displacement with the time taken. That's simply put, the speed of an object in motion is determined by dividing the total distance covered with the total time taken in that journey. That is why the speed is distance per unit time, and the standard unit is meter per second. It can also be in kilometer per hour, as we see rated in vehicles, but you can convert it to standard units of meter per second. Now, let's look at the next quantity is acceleration and retardation. They are opposite terms. Acceleration. When a body takes off from a station and it assumes a speed of motion or velocity, at a particular time, you can see that, for example, a traveling car, it will increase its velocity. Now, when it increases its velocity with time, that gives you the acceleration. We say that the body, for example, a car, has accelerated. Therefore, acceleration can now be put or explained as what? The time rate of increase in velocity. Acceleration of a body can simply be put as the what? The time rate of increase in velocity. Not just time rate of change in velocity, which some people states or defines, which has an error, because the change of velocity of a body there can be increase in velocity and there can be decrease in velocity. So that is where the difference lies. Now, acceleration of a body is the time rate of what? Increase in velocity. That is the increase in velocity per time. That is it. And that part, we now see that the unit of acceleration now is what? Meter per second square. Acceleration is the unit or the formula now can simply be v minus u over t. That's the formula for acceleration. What does that v and u stand for? U stands for the initial velocity of the body, while v stands for the final velocity of the body. Then t stands for the time taken. That is where you get the word, the increase in velocity. Because assuming a body moves with a speed of maybe 20 meters per second, and after some times, the body increased the speed to maybe 50 meters per second. So in that case, the body has accelerated, and the acceleration of the body can be determined by the difference in that velocity, that the increase in that velocity over time taken for the increase. And the unit now is, by implication, is meter per second square. In meter per second square. Then the next thing there, which is an opposite term or quantity, is retardation. Either you call it retardation or you call it deceleration. Now, what is deceleration or retardation? It's simply an opposite definition of acceleration. Now, deceleration or retardation simply implies or refers to the time rate of what? Decrease in velocity of a body in motion. That is the rate of decrease in velocity of a body with time interval taken. That is what? The deceleration or retardation of the body. That is when a car, for example, or a body, let me use a car for instance, is in motion and it speeds up as it is accelerating at a time. If it's coming close to the station where it wants to park or stop the motion, you will notice that the driver of the car will apply brake. On the application of brake, it will slow down. When the body is slowing down from its high-speed motion, it is said to be decelerating or retarding. That is it, which is opposite of acceleration when it speeds up. Now, on slowing down until it stops the motion, the body is said to be decelerating or undergoing retardation. That is it. Therefore, by definition, it is an opposite terminology or concept or quantity to acceleration, which means retardation is the time rate of what? Decrease in velocity, not just change in velocity. That is it. Thank you. Then, we can now look at a similar concept. These are the basic parameters of motion. And from this, we get the equations of motion, which we may discuss next time. But let us look at some concepts that's related to this, which are uniform, concepts like uniform velocity and the uniform acceleration. Yes, some people misunderstand these terms. When we say uniform velocity, we simply mean constant velocity. That is when the time rate of the change displacement of a body in motion is constant with the time interval. We now say that the body is traveling or is moving with uniform velocity. So it can simply be put as what? A constant time rate of change of displacement of a body in motion gives you what? Uniform velocity or constant velocity. That is it. So, for example, if a body is traveling and the speed increases, that for each 1 meter, it takes 2 seconds. For each 1 meter, it takes 2 seconds. We say that the body is traveling with constant or uniform velocity. That is it. The unit remains meter per second. Then, for uniform acceleration, I believe with this explanation, you can simply deduce what this implies, having understood what acceleration is. Very simple. It doesn't need cramming, just understanding the concept, and that's why we are here. Uniform velocity, uniform acceleration now simply implies the constant, when the increase in velocity of a body with time is constant, then we say that it is traveling with what? Uniform acceleration. Therefore, it refers to a time rate of what? A constant time rate of increase in velocity of a body in motion with time interval. That a constant increase in velocity of a body in motion with what? Equal time intervals. So when a body is traveling with what? Constant increase in velocity in equal time intervals, we say that the body is traveling with what? Uniform acceleration. That is, for example, if the velocity of the body is maybe 5 meters per second, and that 5 meters per second increases by 5, next one 10 meters per second, and it takes the body, maybe it takes the body every 10 seconds to cover that. So each 5 meters per second, it takes 10 seconds. So that in that case, in such scenario of motion, we say that the body is traveling with what? Uniform acceleration or constant acceleration. Thank you so much. Then, the same thing applies with uniform retardation. If a body slows down, if a body decelerates, if a body slows down, if the time rate of decrease in the velocity of the body in motion is constant with an equal time interval, then we now say that the body is what? Is under uniform retardation or uniform deceleration. So, I believe with this clear explanation of this basic concept, these are the parameters of motion, I think you have understood it, and there is no confusion anymore. Thank you for your attention and listening to this particular lecture. I believe you enjoyed it. For more of this and also in mathematics, subscribe to my YouTube channel, and you can follow me on my Facebook page. Then also like my page and follow me on Instagram.